Hi guys, welcome to class today. So today I decided to do a video lesson so you guys can kind of kick back and just pay attention here, watch the lesson. What you should have in front of you is the note sheet that's located in the front of the classroom. And then go ahead and put your headphones in, watch the video at your leisure, and there's going to be a homework assignment at the end. So some of these things you can just listen to. Other things I will instruct you in the video where and when I want you to take your notes on, okay? Or where and when to write your notes down. Okay, well, first of all, Pythagorean theorem. It is a theorem that we use in math, and it's kind of more of the most well-known theorems. In fact, I think it's the most popular theorem in mathematics today, and basically we're going to break this down for you. So what I'm going to do is show you how it works and why it works, okay? To begin, we have this triangle right here. And what I am asking of you is first of all, what type of triangle is this? So just think about it for a second. Pause the video if you want to, and just look at the triangle and figure out what type of triangle is it. Well, this triangle is a right triangle. This is a right triangle. We know that because of this square symbol in the corner, because squares have 4 right angles at the vertices. Okay, so what type of triangle is this? This is a right triangle. So go ahead and on the note sheet you can just write right triangle. Now looking at these numbers, these are the lengths of the sides, 3, 4, and 5. Can you think of any relationship, any pattern that you can see between these sides? So let's say we didn't know what this side was. Based on the fact that this side is 3, this side's 4, is there any way for me to get to 5? And don't say add 1 to 4, because that's not the answer. Let's see. Well, if we said 3 plus 4, that'd be 7, which is not 5. If we said 3 minus 4, that's -1. 4 minus 3 is 1. Okay, so what if we did know that this side was 5? Do we still see any pattern? Let's see, 5 plus 4 is 9. 5 minus 4 is 1. Okay, 5 minus 3 is 2. Nope. Okay. Well, there's no pattern there is no pattern between the relationships of these sides. However, what if we were to look at the squares of each of the sides? So 3 squared is 9. 4 squared, 16. 5 squared, 25. Now, what about now? So if we said 5 plus 6, or 25 plus 16, well, obviously that's going to be more than 9. So let's go with the 2 smaller numbers. So 9 plus 16, what does that equal? Well, see, it's 5 and 2, 25. What? That means that the square of this side and the square of this side added together equals the square of this side. So if we found all these values, then we could find the length of any of these sides, really. Because then we could just say what the square root is, because we know this side times this side gives us 25. Well, we just want to know the length of this side. That's 25. Or excuse me, the length of it is 5. Interesting. Very interesting. Well, this is the Pythagorean theorem that deals this theorem only works if we have a right triangle. It does not work for any other type of triangle. So you have to be given, or you have to determine if you have a right triangle by if this angle is right. I will tell you throughout this unit if you have the right triangle. But later on, when you get into geometry, you will have to determine if one of these angles is a right triangle. Then you can determine the lengths of the sides using this theorem. Okay? Now, one thing before we move on is I want to tell you that the side opposite the right angle, this side is called the hypotenuse. Whoops, hypotenuse. This is one of your vocabulary words that's on your sheet you should have. These two sides are called, meet out here, called the legs. These sides are called the legs, hypotenuse and the legs, okay? Now, go ahead and just take a breather and just listen to this for a little bit. So Pythagoras, let's talk about Pythagoras. Pythagoras is the coined inventor of the Pythagorean theorem. He was an ancient mathematician that was born in Greece. He traveled all over Europe and parts of Africa and Egypt in search of more knowledge within mathematics. He was a math brain for sure. He was the founder of the Pythagorean Brotherhood. Some people thought that the Brotherhood was more like a cult because these followers worshipped math, they worshipped Pythagoras himself, but they are the ones that worked together to come up with the theorem. Which brings me to the fact that did Pythagoras come up with the theorem, or did the Brotherhood as a collective come up with it? Well, we don't know for sure, but we definitely do give the credit to Pythagoras, which is very common that one person usually gets the credit when many contributed to the end result. Okay, back to it. Just a little brief history break for you, but back to it. So vocabulary. I'm going to go through these a little bit quickly, but what I want you to do is pause the video when I get to the end and go ahead and write all these definitions down. Okay, so right angle, 90-degree angle measure. That is the definition of a right angle. The legs, I kind of briefly talked about them, but to give you a little bit more of a specific picture, the leg they are both the sides that meet to make the right angle. What I mean is, here's our right triangle, here's our right angle. This side and this side meet to form our right angle. Therefore, they are the legs of the right triangle. The hypotenuse is the longest side of the right triangle, and it's the side opposite the right angle. I recommend that when you are working with the Pythagorean theorem that you always draw an arrow from the right angle across to the other side and then write hypotenuse there. That way you will never wonder which side it is. Square root, as we have gone over in the past, square root is a number that when multiplied by itself gives us this number. So what number, when multiplied by itself, gives us 16? I hope you all have said 4, because that is correct. So 4 times 4 times 4 equals 16, or we write that as 4 squared equals 16. So the square root of the square root of 16 is 4. Or I should put that right here, is 4. So as always, every theorem will generally comes to some sort of a formula, and this is the formula for the Pythagorean theorem, with A and B both being legs and C being our hypotenuse. So let's look at this for a second. Let's go back to our 3, 4, 5 triangle, okay? 3, 4, 5. We essentially did 3 squared plus 4 squared equaled 5 squared. But I want to focus on this side of the equation. Is 3 squared plus 4 squared the same as 4 squared plus 3 squared? Well, let's see, we have 9 plus 16 and 16 plus 9. Are these the same answer? Ding, ding, ding. Yes, they are. They're both 25. So, which side you label A and which side you label B as far as the legs go, it doesn't matter. Just be consistent, okay? But this side is always, 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 always. The hypotenuse is always, 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 always C. Always, always, always. So on the front of your note sheet, you should have a right triangle. Go ahead, label your sides with the correct corresponding variables and terms for each side. I don't care. These are interchangeable. So what you label, it doesn't matter. One could be A, one could be B, doesn't matter, could be B, and then A. All right, steps to solving your a missing side of a right triangle. First, you want to identify which side you're finding. Are you finding a leg or a hypotenuse? Next, you assign your A, B, or C value to each side. Write out the equation in your a squared plus b squared equals c squared form, so plugging in the lengths of the sides into that equation. Then you perform the order of operations. Don't forget PEMDAS. Parentheses, exponents, multiplication or division, whichever one comes first, and then addition or subtraction, whichever one comes first. Then we solve for our missing side, we solve for our variable, and last but not least, we label with units of measure. So what that means is each side, it should be like, for example, all in inches, centimeters, meters, yards, whatever the unit of measure is, then you label your answer. Okay, getting into an example, we first want to identify what side we're going for, which this is the side that's opposite the right angle, which makes it the hypotenuse, which is our C value, always, always, always the C value. So let's set up our equation. It's a squared plus b squared equals c squared. And we label our sides. The legs are interchangeable. So we have 8 squared plus 15 squared equals, we do not know our c value. 8 squared is 64. You all should know from the last few weeks we've been going over our squares and our square root values. So we add these two sides together, which we get 9, 8, and 2. So this becomes 289 equals c squared. And in order to solve for c, we square root both sides, which means our missing side is 17. And we don't have a unit of measure, but normally we would put that right there. Okay, let's do another one together. So what side are we missing? Well, we know that this opposite side from the right angle is our hypotenuse, which is labeled as C, always, always, always. And that makes our missing side a leg. Now, could this be A or B? Yes, it could be either or. I'm going to do A and label this B. Why not? So we write out our equation. And A is our missing variable, so a squared plus, and then we have 9 squared equals 15 squared. And following our order of operations, we do 9 squared, which is 81, equals 15 squared, which is 225. Now we're adding 81 over here, and we want to get A by itself, so we're going to do the opposite by subtracting 81 from both sides, which on the fly over here, really quick, 225 minus 81 gives us 4. I'm going to borrow there, gives us 4 and 1. So that means A squared equals 144, which means that A equals 12. So our missing side is 12, and then our unit of measure would go there. So that is how you solve for missing sides. What I want you guys to do is go ahead and you can work with a partner and work on these homework problems. Hopefully for most of you it will not be homework. And I will see you tomorrow. You guys have a great day.